Okay, I think we'll get started. Hello everyone, welcome to the chromec webinar on the Guided Radiation Interdiction Detector, or GRID, backpack system. This is the latest webinar in a series of webinars by Chromex, kind of covering our products and all of our different technologies that we're able to offer. Feel free to visit chromec.com/events to see the other events that we have coming up and if there's any other webinars or any other events that you might be interested in. So today I'm going to talk about the GRID backpack-based system, which is a technology developed between both Chromec and Physical Sciences Inc., or PSI. Chromec and PSI work in partnership to deliver the best possible solution for this product with Chromec detectors and PSI's revolutionary identification algorithm in there as well. Just a little bit about me. My name's Eve Paler and I'm a product manager here at Chromec and I look after the nuclear security products. So I'm responsible for products for both the nuclear security and civil nuclear markets. And as a product manager, I work closely with customers to understand the application and the requirements and to understand the market need as well more generally. During this presentation, we're going to cover the GRID backpack system. We're going to cover its key benefits, the detector technology that's used within the GRID backpack system, the user interface and the smartphone-based interface that you get with that. We're going to talk about its added uses and different ways that you can use the detector technology, different applications as well, and the usability of it. Chromec provides radiation detection solutions globally in 3 markets. This includes nuclear detection, medical imaging, and security screening. And Chromec is a UK-US company with its headquarters in the northeast of England, but we have extensive manufacturing sites in both the UK and the US, and we sell our products globally. So the Guided Radiation Interdiction Detector System, or the GRID system that you can see here in the centre, which is in a backpack. So that's a backpack-based system which can be used to detect radiation from both gamma and neutron sources. It has a smartphone interface, which you can see there. So you get that backpack that you can easily wear on your back, and the smartphone interface, which you can use to get all of the data. The backpack itself and the detector in there houses 3 Chromec D3S detectors to enable a source to be easily identified and located. All of the information from those detectors is sent to the really easy to use user interface on that smartphone. The device uses PSI's award-winning state-of-the-art Poisson cluster split, or PCS algorithm. This means that we're able to deliver unparalleled threat detection, identification, and source directionality. So for an operator, what that really means is that as soon as a source is detected, it's immediately and accurately identified as a specific isotope or as a combination of isotopes if there's more than one isotope present. The algorithm also provides a vector to source and a range to source, so you'll be able to see where that source is and the range to that source very easily. So this is truly actionable information. So as soon as the source is located, the operator is given the information needed to quickly interdict that source. Not only does the PCS algorithm allow the system to accurately identify those sources, it provides increased sensitivity due to its ability to extract small signals from noisy environments. So as a result of this, GRID meets and exceeds the ANSI N42.53 standard for gamma detection, but at substantially lower false alarm rates as well. So it's meeting all of those international standards that would be needed. I'm going to talk about the low false alarm rate, but it greatly exceeds the stated false alarm rate in N42.53. The device is also really lightweight. The detector in the backpack and the whole backpack system is really lightweight and easy to wear. You have that simple user interface on the smartphone, which I'm going to go into in much more detail and kind of show you the different aspects of that UI. As you've got those Chromec D3S detectors in there, you're getting both gamma and neutron detection as well. And you've got that backpack-based system, which has hot swappable batteries as well, so you can prolong the life of the device in the field. So the D3S detector was developed in 2014, and there are now thousands of units out in the field in 25 countries. So it's already deployed and it's already proven technology. The grid backpack, as I've said, houses 3 D3S detectors. You have one on the left-hand side, one on the right-hand side, and one at the back of the device, of the system, so you can get those 3 areas of coverage. So the 3 D3S detectors, they all have a cesium iodide gamma detector in there. They also have a non-helium-3 neutron detector. You're able to get a gamma resolution of 7% from those. You're also able to detect gamma in a wide energy range, so anywhere from 30 keV to 3 MeV. As with all chromec devices, you're getting a really great sensitivity there for both neutron and gamma. And a really important factor, especially in this backpack, is that the detectors are really small. So you're getting detector dimensions which give it a really small form factor. The D3S initially is designed to be wearable, so it's a wearable detector that someone could wear on their belt. It has a weight of 237 grams, so extremely lightweight, very easy to carry in the hand. So this makes it ideal for use in a backpack because even though you have those 3 detectors in there, you're still getting a really lightweight device which can be used and can be carried for a long period of time. So you're going to get that superior detection, but in a really small, lightweight package. Also got an operational temperature between -20 to +50 degrees C. And that means that you can use the device anywhere. So the grid backpack can be easily used anywhere that it might be needed. Okay, so I'm just going to talk about some of the key features of the grid backpack. So a really important factor here is that the grid has an operational false alarm rate of 1 in 340 hours. And this reduced false alarm rate is really important because it's one way in which operator burden is reduced with the grid system. This is because there's less false alarm rates that require adjudication, so you're not needing to go through that whole process of adjudicating that alarm for something which isn't a true alarm. This means operators are able to cover more area in less time, and the actionable information provided by the system further reduces the cognitive and operational burden associated with adjudicating detections. So the operator isn't continuously having to go through that entire adjudication process. They know when they get an alarm, it's a true alarm that they have to take action with. So as a result, not only are operators able to work more efficiently, they're also more sensitive to real threats. So there is a very real risk with repeated false alarm rates that the operator's sensitivity to them is just reduced. So if you're getting a false alarm every hour or every couple of hours, then an operator could very easily dismiss those alarms without adjudicating. So we want to make sure that you're getting truly actionable information where you can use that information in the way that's needed. You're also getting instant detection, identification, and localization. So you get that detection instantly, it's near real time, updated in 1 hertz, and you get any changes to that as well. So I'll show you that point when I show you more about the UI, but it updates to show you if you've moved past a source, you will see that the angle to that source has changed. The design is really lightweight. There's obviously a very physical element here when you have the backpack. So it's designed to be worn by a person. It's designed to be worn for a long period of time. So that's another way that operator burden can be reduced. So the entire backpack system with the features, everything included in there, weighs only 5 kilograms or 11 pounds. And this leads the market in terms of lightweight, high performance systems of this kind. You'll also notice, you can see on the backpack picture there, you can see that it has a really small footprint. The backpack is a camel mule, which has ventilated back panel and ventilated shoulder straps. So it's designed for mountain bikers, runners, other outdoor enthusiasts. So this means it's lightweight, it's really cool for the operator to wear. And really importantly as well, it rides comfortably on the upper back, which leaves the waist area clear for a duty belt or any other equipment that may be needed. So it's not going to interfere with any other equipment that may be required. Even the user interface is designed to minimize operator burden. It's a very simple smartphone app, and it's extremely intuitive and easy to learn, and comes with some key features like clearing maps and localization of sources, which I'm going to show you. Okay, so onto the UI. I'm going to show you a video of this is the radar view here. So the app, which accompanies the grid system, runs on an Android-based smartphone and connects to the backpack via the local Wi-Fi network. The top half of the display shows that the display can be switched between two different types of displays. So you have the clearing map there, and you also have the radar view. So scrolling up from the bottom, you can see the past alert events are shown in the alert history tab. The radar view contains a localization plot which shows the relative magnitude of the 3 different gamma detectors in green, as viewed from the top of the operator. So you can clearly see the operator there in the center. The display is updated every second. So when an isotope is detected, so you can see that americium-241, an audible alert will sound and the dominant isotope in the direction relative to the operator will be shown. So you can see there that red wedge shows the vector to source information, and an estimated range to source is also shown when that's available. The current detection and ID is shown at the bottom, and as the detection continues, the information is updated every second to reflect those changes. So you can see as someone moved past a source, it would move as if it was behind them. Just scrolling up, you can see that alert history section there. That shows past and present notifications, and a summary of each investigation is shown in that history as well. So you're getting a date and time, you're getting the ID, you're getting the classification, a range when that's available, and a location as well. So you can very easily go back to that information if required. So the other tab at the top there that you saw when it navigated through the 2 top panels is the clearing map. So a clearing map is used for visualizing where you have cleared for radiological threats. The map is touch sensitive with a drag and a pan and pinch and spread for zoom. So you've got your drag to pan across that screen, and just as you usually would. You've also got a vectorized road map that you saw there, and the visual satellite image, so you can toggle between those different maps. The current location is shown in blue there, you can see at the center. And you can set that to remain in the center by clicking the center on location button. So to define a clearing map, you just click on the pen icon at the top there. The boundary can then be drawn with your finger. Clicking the record button starts the clearing process. You can pause that clearing map at any time to suspend the clearing process. So the area yet to be cleared is shown in red, and the area that has been cleared is shown in blue. So as you move through that clearing map, you would see more of that area start to turn blue as the operator moved through more of that area. Okay. So I'll just show you a quickly speeded up version of this, so you can see as an operator is moving through that section, you'll be able to see more of this turning blue and kind of see what would happen there. So you can see what in blue is where the operator is currently. And as they begin to move around that map, you can see more of that turning blue. You can have that either on the vectorized view, or you can have that on a satellite image as well, depending on preference or depending on need. So here I'm just going to show you that UI in action in a real sort of situation. So this is where there's an assessment of a car park being taken. So as we see, I'm wearing the backpack and seeing the UI on that screen there. You can see as he walks past that car, he gets an indication that there's something on his right. You can see Cobalt 57 in one of these 2 cars. So you can move between those. he gets another indication that on his right there's cobalt 57. So that means that he can narrow it down to that one car. So in addition to it actually being used in the backpack, you can also use the grid system as a temporary stationary node. The enclosure of the system within the backpack is durable, light-resistant plastic. The reason why plastic is used is because it provides the mechanical and environmental protection that the detectors need without significantly attenuating that gamma signal at all. This module stands on its own and actually includes a thread on the bottom of the system and slots along the side. And this means that you can connect it to a tripod via that thread, or you can pass nylon straps through the slots on the sides to anchor it to a pole or a different piece of infrastructure. So in some cases, it may be sufficient to actually set this backpack down and just use it like that as a temporary stationary node, for instance, to entry to a stadium or some other public venue. So you have that kind of flexibility with it. You can either just set it down, use it as a node, you can fix it to infrastructure, you can fix it to a tripod as well. So you also have the ability to connect the device to mains power or operate on batteries as well. The batteries have a life of 8 hours, however, can be easily swapped in the field by simply unclipping them from the back of the system. So you're getting that really flexible option on powering the device as well. You can either use mains power or you can use batteries. Grid in the actual system has its own GPS system. So in most situations, the user has good GPS. It's really easy to navigate and generate clearing maps very easily using that satellite imaging and those vectorized views that we've shown. Clearing maps are obviously a really great tool for the operator because it allows them to accurately see which areas have been cleared and where they still need to go. In a place where you might need to use this system that is GPS denied or has a GPS lock, you can still generate those clearing maps and still use that functionality using the stereoscopic cameras here. So the operator would simply snap a picture. You can see that it's at the front of the person's chest, kind of between those front two straps. You can use that to take a picture of something like a floor plan or a 2D drawing of the layout of the place where you're wanting to assess, and you can then use that to generate those clearing maps as well. So it can even be used in GPS denied areas. So you're getting, again, that flexibility to use it wherever is needed. The grid backpack system can be used in a wide range of applications, as the hands-free sensor enables the user to perform wide area search operations for radiological materials of interest. This is especially useful in situations where radiation search surveys of large crowds or high-profile events are performed. The system can be used effectively in homeland security, interdiction and elimination operations. The system is particularly useful in radiological and nuclear or RN sensitive site assessments and sensitive site exploitation operations as well. And this allows you to systematically locate, secure, characterize and disable weapons of mass destruction programs and related capabilities. The system will support operations by providing increased RN detection, localization, presumptive identification, and field confirmatory identification as well. Within the military space, the grid system can provide the capability to detect and identify weapons of mass destruction prior to use. So obviously really important applications here, essential that you have the right information that is needed at the right time. The grid backpack-based system can also be used for event security, as the high sensitivity of the D3S detectors and excellent PCS algorithm technology mean any threats will be detected. The backpack system, with its hands-free operation, allows the operator to perform inconspicuous searches in public areas. So you're getting a really inconspicuous system which can be used anywhere at any time. The grid system offers many benefits when being able to interdict radioactive sources. In addition to the system's excellent detection capabilities and sensitivity, the system also greatly reduces operator burden as well. The 1 in 340 hour false alarm rate that I've mentioned previously reduces the likelihood of nuisance alarms, and this ensures that the operator doesn't become desensitized to real threats. It also reduces the cognitive load on the operator because the number of alarms is restricted to true threats, meaning that they don't have to waste time adjudicating those unnecessary alarms. The lightweight design, with a weight of less than 5 kilograms or 11 pounds, means that the backpack can be easily worn in a hands-free manner for a long period of time. And the small form factor of the backpack means that it can be easily worn on the upper back and doesn't obstruct any equipment that has to be worn around the waist. The system itself is very easy to use. It has a user-friendly interface which provides truly actionable information which can be relied upon in the toughest times. The system also has reach-back capability, meaning that files can be sent from the field for secondary adjudication by a radiation expert. These files are all sent in the industry standard N42.42 file format. So overall, with Grid, you're getting a system which provides a full radiation detection solution with highly sensitive proven detector technology, which gives truly actionable information in a package which is also really small, lightweight, and can be worn and operated easily on the back in a way that is unobtrusive and inconspicuous. Okay, thank you everyone. Thanks for taking the time out to listen to the introduction on the Grid system. So I have seen some questions coming in as we've been going through in that Q&A feature. Feel free to, if you do have any questions still, feel free to ask any of those and we can get back to you. There's quite a few questions here, so I'll answer as many as I can in this time and get back to you on any of the ones that I can't answer. Okay. So what do I see on the smartphone when neutrons are detected? So you'd see roughly the same thing that you see when you get a gamma detection. So in the localization mode, so that mode where you see the 3 different detectors shown in green with their magnitude, their relative magnitude to each other, you would see in that screen, you'd get an alert which said neutrons detected. So you'd get that audible alert. And you'd also see the direction on the screen as well. So you'd be able to see if it was to the left or to the right, and you'd be able to ascertain where that source was coming from. Okay. What materials can be used to make a clearing map using the camera on the front of the backpack? Okay, so that's a stereoscopic camera, which is located at the front of the backpack. So it's between those 2 front straps. So you can take a photograph of any 2D representation of the ground that you're wanting to clear there. Something like a floor plan is what I mentioned. That would be somewhere like an office building, or any 2D drawing of the layout, for example, somewhere like a ship hull. So you could take a photograph of any 2D drawing of that and you could use that to build up those clearing maps. Yeah, you just take a picture with that stereoscopic camera and you're ready to go. Okay. Does the backpack system meet all elements of ANSI N42.53? Nice answer to this one, yes. It meets all and exceeds many of the areas in this standard. A particular one that I've mentioned a couple of times in this presentation is the 1 in 340 hour false alarm rate. So that greatly exceeds the specification in ANSI N42.53. So that 1 in 340 hour false alarm rate is one of the ways in which it exceeds the standard, but it does meet every element. How many past sources can be stored? Okay, so I assume this relates to the alert history. In the alert history section, which you could see when you dragged up that bottom menu on the radar view, you could see that you could save some sources there. You can see all of the history, everything that's been detected. The past 100 alerts are shown and that information is given for each, so you get that. Things like the isotope that's been identified, the time, the location, the range, all of that. So you get that for the past 100 isotopes. or 100 alerts if it's a neutron alert. Okay, I think I might just have time for one more here. Is there a way for me to see multiple backpacks from one location? Yes, we have a lot of networking options available for the backpacks and for all of our detectors. I would say it would be, if you are interested in a specific networking option, or you have a networking system already in place, or something you want to look into, I would say please reach out to our sales team, because they'll be able to instruct you on the best option for you and for your needs. Okay, I think that's all that we have time for today. I will get back to any of the questions. I can see there's a lot more questions here that I haven't had time to answer, but I will get back to you with answers to all of these. I'd like to say thank you, everyone, for taking the time out to participate in this. As I said, this is one in a series of webinars by chromec, so please feel free to look at our future events on chromec.com/events. And also, if you'd like any more information about any of this, or have any other questions that you think of after the webinar, please feel free to reach out to our sales team at sales@chromec.com. Thanks, everyone.